I will be presenting few interesting structures which are getting built in and around Mumbai, mainly in obviously structural steel. We Spectrum Techno consultants basically working in this area for last 20 years, based in Navi Mumbai, Vashi, and doing number of flyovers, bridges, and other infrastructure projects. So I've selected few structures here for this presentation. Before that, I would like to, obviously all of you know that steel is quite a versatile material. And whenever we can't use a concrete in infrastructure project, the steel comes to help to us as a designer and a contractor. And many of the infrastructure projects get realized because of this particular material. So, advantages is a versatile material, especially in urban infrastructure, where there is a lot of traffic, utilities, and so on. And compared to concrete, steel is lightweight, is in construction, erection, economical substructures, foundations. Obviously, leads to the speedy construction. It's taking a lot of time. What is happening? Again, better quality compared to the concrete. And the most important is the recyclable. So it is a more sustainable material as compared to the concrete. So with this, why there is that much lag in the, I have to point somewhere else. Yeah, so I'm going to present a few projects, which is and these projects are around this particular place. Santa Cruz Chembur Link Road, which we call as the SCLR, Shivdi Worli Elevated Corridor, which connects the MTHL to the coastal road at Worli, Metro Line 2A, 2B, and Line 6. Why there is so much delay in the... And there is one important process going on at Mahalakshmi, which is a cable stay bridge over a railway. Okay, so Santa Cruz Chembur Link Road, SCLR, 2 case studies. Yeah, if you see this is the alignment. I don't know whether you will able to. Okay, so this is the Kurla end. How to use this pointer? Pointer can. Can I use a pointer here? Yeah, okay. I have to show it here. This is the Western Express flyover, and this particular part is coming from the Kurla, which is over this Bugara Road, that is a Hyatt hotel. And then that particular highway has to cross over this Western Expressway and go towards the Mumbai airport. Okay, so it is a sharp bend, and earlier the DPR consultant planned few foundations along this alignment, but later on they realized there is an underground metro. There are a number of utilities like a large water pipelines, and it was not possible to put any foundation nearby. So how we have to plan this particular bend without any foundation in between. So obvious solution was the cable stay bridge, and that also in a structural steel, because concrete was again not possible there. Where I have to point it? Where here, there. Okay, so this is the elevation, and you can see that is the flyover, and then there are there is an underground metro also, and this is what that particular model. This is the Western Expressway, and these are the flyovers coming from that Bugra mark. So this particular span, which is a 100-meter cables, 100-meter span with a sharp curvature. Yeah, this is another view. The construction of this pylon is going on. If you are traveling along this road, you can see the that pylon is coming up. Yeah, this is another view. And this particular span is in a structural steel. It is a box. This is what the analysis model in a sophistic. Some few board shapes. These are the few details of that particular box in a steel. This is a cross section, and these are the Techno models. And those are the cables which are getting anchored to the box. Yeah, this is a pylon with the cables in the legs. These are the few details of this steel box, which is getting connected to the concrete pylon. So that was the one study. Second was there is a 65 meters, again curved box girder at a BKC, which is again, see that kind of a curvature in the cable stay in the earlier case study, it is never done anywhere in the world. The first time we are doing it here in India. And many consultants have raised their hand for a proof checking. So finally we have to approach one consultant in Italy, is the Mario Miranda, and he finally proof checked and approved the design. The second similar structure was a 65-meter curved span that is coming in a BKC. Again, here also, earlier there were a few foundations with a 25-meter center to center. Again, they realized there is after this project was conceived, the bullet train was passing under this, at this particular location underground. So we have to knock off few foundations, which are that PR5, PR6 and PR7. So that span become quite a large, which is about a 65 meter on a curvature. So again, we have to take a help of a structural steel. Yeah, this is the half, this is the elevation, this is the plan. These are the, it is a composite trapezoidal box. These are the dimensions, the height is about 3.2 meter, and after the casting of a deck slab, that becomes that section becomes a composite. And being on a curve, there is always a instability, and then we have to provide the bearings. Yeah, so here we have to take this diaphragm bit away to take care of the stability of that particular curved box girder. These are again the analysis model. You can see that particular diaphragm which is taken out for the stability purpose. So this was the second case. Yeah, these are a few photographs during the construction. And now that particular stretch is open for a traffic. Then there is another important project which is the Shivdi-Worli elevated corridor which connects the, here is that at the bottom you can see the MTHL which gets ended at the Shivdi location, and there is a coastal road which is ending at Worli. So we are going to connect these 2 points as a, across the Mumbai, and very congested old Mumbai, and number of problems for the planning and the layout, alignment, and going into very congested area. So again, the structural steel has came to rescue for this design. You are operating or? Okay, so there is a parallel TT circle where we have to provide a 100-meter span, and that and they wanted to have a very aesthetically good-looking structure, which is this is a plan, and the span is 100-meter. Yeah, so this is a network arch. See, the difference between your conventional arch and network arch is these particular cables are meant for either it can be a high strength bars or it can be a strands or cables. And because of they are crossing each other, that plane becomes very stiff. And the bending moment in this arch as well as the bottom, they are very, very less. It is almost like an axial force carrying members. And that's why the structures become very light and very economical. The weight of this 100-meter span with carrying 4 lanes of the traffic is hardly 420 tons. Otherwise, if the conventional arch or truss, it takes about some 800 tons. So that much reduction in weight is there because of that particular form of the structure. Yeah, this is again a model in the sophistic, that software. There is another 2-span continuous box girder, which is 60 meter and 65 meter, which is again near Worli, towards that Oberoi tower. These are the plan and elevation. And this is again a typical cross section of a composite box. Again, we have to take a bearing out to take care of a stability. And these are the actual 3D models. That particular link is crossing the over one monorail station near Hofkin Institute. And that station itself is about a 70-meter long, and we have to take that flyover over the station, so the span becomes about 85 meter. So how to erect that span over the station, which is already in operation of a monorail, that was a challenge. So again, we have to resort to the structural steel. So this is the station, the hatch portion is the monorail station. The upper one is that our flyover. The height is almost at 25 meter from the ground. So there we have, yeah, this is the plan for the station. So we resorted to this multi-box. There are 4 boxes. Each box is weighing about 250 ton. So they are going to fabricate besides the station, get lifted, and then they will side shift on the pier. So again, this particular solution was not possible in a concrete. These are a few analysis models. Then we will move to the metro projects. This is the one underslung girder, which is a 75-meter composite truss for line 2A near Malad. See, generally for a metro, for such a span, people go for a open web truss. And once you have an open web, the width becomes quite large. Actual width for the metro is 10 meter, and then if you want to have a truss, the web to web distance becomes almost 13 or 14 meter. Because of this underslung, only 5.5 meter, we could able to accommodate this particular truss. So this is underslung, means the and the metro is running on the top of this truss. There are two nalas, and that's why to cover this nala, we have to go with that particular span. Yeah, these are the various, the elevation, top and bottom plan. This is a cross section. With the only two waves, we could able to manage this dimensions. So this was also first time it was done for the metro, and now many locations it is getting, the design is getting repeated, copied. And this was the construction method. First, we are erecting a trestle over which the bottom chord is installed. And this is the completed span. And this is a load tested once the span was completed. Same thing, same solution we have used for a metro line 6 also, which was a 78 meter. Only difference is in a metro, line 6, the span was, the metro was on a curved alignment. So we have to provide 4 waves to take consider that overturning moment or centrifugal force. These are the various details. I will not go into details. These are some views of the Techno model. Same thing is for the similar thing. We have done it for a 54-meter span, W type through girder for a metro line 6, which is crossing line 7 at that particular location. So the metro line 7 plus there is a Western Express highway, and both it is getting crossed. So this is the photographs during the construction. Again, another same span girder at a different location.
Minutes, sir, please.
Yeah, it's over. So, and this is a. Then there is a one cable stay bridge on a ROB near Kalanagar for a metro line 2B. This is that railway, and then there is a flyover, and above the flyover that this particular metro is passing. So this is a some artistic view of that particular metro. Again, the span is completely in a steel pylon as well as a central and side spans. So this is again a one model for a soft stick. And this is the last project, which is the Mahalakshmi ROB over Mahalakshmi railway station. This one span over this railway is a 165 meter. The pylon is 65 meter tall, and everything except the back span was in a concrete to balance the bending, the stability moment. But the main span and the pylon both are in a structural steel. So that the pylon construction is going on. So maybe in the next still days, we will present this complete case study. So this was the last, and this is the one bridge we are doing it over river Ganga in Varanasi, Kashi. So still you can have a very aesthetically and architecturally pleasant structure. So thank you very much.